So today we're going to be talking about linear systems, which is essentially two lines that we see on the same graph. And when they intersect, what that means and what kind of information we can extract from the graph and both of the lines. So to set things up, two cell phone companies charge a monthly flat fee plus an additional cost for each minute of time used. The graph below shows the time versus cost relationship for 1 month. So we have a company called Talkmore and we have a company called WeTalk. Talkmore is represented by the red solid line. WeTalk is the blue dotted line. What is the point of intersection, or the POI, and what is its meaning in relation to the cell phone plans? So if I look at this, the point of intersection, where these two lines cross, is right about there. So if I was to look at the X value for that, it is clearly at 500 for the X, and it is clearly at 55 along the Y. So the point of intersection is 500 and 55. My X is 500 and my Y is 55. What is its meaning, what does it mean? Well, this is when both cell phone plans cost the exact same. Both plans cost $55 at 500 minutes. Under what conditions is it best to use the Talkmore cell phone plan? So Talkmore cell phone plan is the red. Ooh, get rid of all this. Is the red. The better conditions would be when it's cheaper. So when is the red line below the blue line in terms of cost? Well, we can see that after 500 minutes, the red line is less costly than the blue line. So that tells us when is it best to use Talkmore cell phone plan if you use more than 500 minutes. More than 500 minutes. Under what conditions is it best to use WeTalk? So WeTalk is the dotted line. The dotted line is lower along the cost scale when it is before 500 minutes. So it's better to use WeTalk if you're going to use less than, if you use less than 500 minutes. So a linear system, or a system, is when two or more lines are graphed on the same grid. The point of intersection is the point where the two lines cross. Another way to say the point of intersection would be the solution to the linear system. So our examples here, a linear system can be represented as two equations. We have one equation, y equals 2x plus 1, and we have another equation, y equals 3x minus 1. So if I tell you that the point 25 is the point of intersection for the linear system, basically that means if I plug in the x value and the y value into both of these equations, we're going to get the same balance, or we're going to get y is equal to 5, or they're both going to balance out. So I'm going to quickly identify my x and my y, and I'm going to, it says sub in x is equal to 2, and you will get y is equal to 5. So I'm going to do that method first. So I'm going to leave my y. Y is equal to 2 in bracket 2, because that's the x value, plus 1. Y equals 4 plus 1. Y is equal to 5. Now, is our y value 5? Yes, it is. So if I plug in both values of x and y into the equation, because this is another way you could do it, they need to balance out. So I'd have 5 would be equal to 3 and in brackets 2 minus 1, right? Because our x value is 2, y value is 5 from what's given here. I would then have 5 is equal to 6 minus 1. 5 is equal to 5. This balances. Left side is the right side. Therefore, this point of 2 and 5 does in fact fall along the line of y equals 3x minus 1, and it falls along the line of y equals 2x plus 1. We prove that here. So that means that the point of 2 and 5 is the point of intersection between these two lines. So our second example, iTones and MusicMine are two online music providers. Each company charges a monthly membership fee and then a per song download rate. We see iTones is $10 a month and then $1 per song. MusicMine is $7 a month and then $1.50 per song. So write an equation for each music provider where C represents the total cost for 1 month and N represents the number of songs purchased. So, oh, wrong color. If I go to iTones, the cost is, well, the rate they give is $1 per song, $1 per song, or N in this case, plus $10 a month. MusicMine, the cost would be equal to, well, the rate is $1.50 per song, $1.50 per number of song, plus $7 per month. Now we need to graph the lines on the same graph. Before we do that, I'm going to show the additional step of how we get our coordinates to place on the graph. So if you create a table of values for each of these equations, it would look something like this. I just substituted S for number of songs, N is above. Either way, it's the same equation. So if I take the X value of 0 and plug it into where our X would be, I would get something at the end of this. So my Y value when X is 0 is 10, which makes sense because this is our slope form. We know this is our B, or our y-intercept. Our y-intercept is 10. That makes sense. When X is 0, Y is equal to 10. When I take 2 and I plug 2 into the equation, so 1 times 2 is 2, plus 10 would give me a value of 12. I take 4 times 1 is 4, plus 10 is 14. 6 times 1 is 6, plus 10 is 16. So I'm setting these coordinate pairs for this relation. So when X is 2, Y is 12. When X is 4, Y is 14. And we'll graph that in a second. The other company, MusicMine, again, if I plug in 0 for my S value or my N value, I would simply get 7. When I plug in the X value of 2, I would get 2 times 1.5 would be equal to 3, plus 7 would give me a value of 10. When I plug in 4, I would get 13. When I plug in 6 times 1.5 is equal to 9, plus 7 equals 16. So now I have those points that I'm going to go ahead and plot along the graph up top. So I'm going to start with iTones. It started with when X is 0, when X is 0, Y is 10. When X is 2, Y is 12. When X is 2, Y is 12. When X is 4, Y is 14. When X is 6, Y is 16. And we can see the relation and how that would look if we were to graph it. It would look like this. Now, I'm going to graph MusicMine. When X is 0, Y is 7. So I'm going to plot 7. It's going to be right around here, roughly. When X is 2, Y is 10. So when X is 2, Y is 10. X is 4, 13. This is 4, 13 would be right around here-ish. When x is 6, y is 16. Oh, look at that, right along that line there. So or that spot there. So if I go ahead and draw this as best I can, that would be MusicMine as a graph. So if Lulu plans to purchase 7 songs this month, which is the best plan for her? And explain. So she's looking for 7 songs. On 7 songs, which is cheaper to use? Is it iTones or MusicMine? Well, iTones is actually less cost when you have 7 songs. So if she's buying 7 songs, she should use iTones. Because it's less at 7 songs. Less money at 7 songs. Something like that. Which plan is cheaper if you only plan to buy 4 songs per month? How do you know from the graph? So I'm looking for 4 songs per month. All right, the first line I see is green, which is MusicMine. So MusicMine is cheaper. At 4 songs. How do we know from the graph? Well, we looked at it. It is less, or it is further down the y-axis, costs less clearly than iTones at that number of song. What is the point of intersection of this problem, and what does it mean? So the point of intersection, if we go to the graph here, we can see that it clearly, both lines touch the point 6 and 16. So the point of intersection is 6, 6 and 16. What does it mean? It means that for both plans, it's the same when you purchase 6 songs. It costs the same when you buy 6 songs. So if we didn't see that on the graph, I mean, the graph does a pretty good job of showing us visually, hey, these are where these 2 lines touch. If you picked up on the fact that both 6 and 16 appear in each table of values that we created, you could then just say, okay, the point of intersection, 6 and 16, those are the exact same. Therefore, this is the point of intersection for both of the equations. But the graph does a really good job of simply showing that. So when you have 2 lines or 2 equations of the line, wherever they touch is the point of intersection, and we can determine what that is by using calculations from the equations of the line and then plugging in values to see how they graph, and then looking at the graph and seeing, okay, this is where the point of section ends up being.